Hello everyone. Today we're going to go over a little bit with solving our first problem set with Projectile Mania Worksheet 1. A couple of things here I'd just like to point out are two equations that we're going to use. We have one here on the left. This is whenever we're solving for the time. We need to take the square root of 2 times dy, which is our height above the ground, divided by the acceleration of gravity, g. For the how fast something's moving, our equation is velocity equals dx, which is also known as the range of the projectile, how far away from the base that something lands. X is horizontal, y is vertical, and we have the time. Typically, we need to solve for the time over here on the left-hand side first. Then once we have the time, we need to plug it in over here on the right-hand side, and then we will find our range. A couple things that I want to point out. Number one, please make sure when you're using G, G is 10 meters per second on Earth. This is not typically given to you in the problem, but it is something that will go in the equation every single time. Just please keep in mind, I noticed this whenever the virtual students were doing the free fall calculations. It is very easy to type in the question into Google. However, because I do not use quite as exact value as what Google will, if you ask Google for the answer to the question, you will get the wrong value. Just keep that in mind. Please plug in. You will not have that many problems to do in each problem set, but please make sure you're using G is 10. Google will use 9.8 as an accepted value for the acceleration of gravity. When we're going through with an example calculation, and I want to make sure that we're going through, please type this in your calculator to make sure that you're getting the same value, because it really depends on what calculator you're using as to how you enter this in a calculator. If you're using a blue calculator or maybe a yellow calculator for math class, you can type it in, everything underneath the square root. If you're using a computer calculator, you will need to do it a little bit differently. But I wanted to use this example. Please make sure that you're getting the same answer that I do when you plug it in. So if I want to find out what the time is a square root of 2 times 45 divided by 10. Now, in my computer calculator, I want to do everything underneath the square root first. Then I just want to take the square root of that number. So if I take 2 times 45 divide by 10, I want to take the square root of 9. Now with my computer calculator, I need to press square roots, or I need to have the number in here first. Then I take the square root, and my answer is 3 seconds. If I'm using Google, I can pull that calculator up. Calculator. So again, I pretty much have to do the same thing. I do everything first. 2 times 45 divided by 10. Then I'm going to come over here and press the square root. I'm going to take the square root of 9, and then that's going to give me an answer of 3. It looks like with Google's calculator, if I press the square root button, 2 times 45 divide by 10, close your parenthesis, equals, you get the same answer. So please be careful with however you're putting that in. But if something is 45 meters above the ground, it takes a total of 3 seconds for it to land. All right, let's go ahead and take a look here at our examples for Projectile Mania. The biggest part with this is making sure we identify dx and dy correctly. Okay, so just coming back here to our practice problem, I did notice a little mistake that I had to fix real quick on the practice problem here. But the biggest thing that we have to make sure that we do is identify what is the dx, which is known as our range, and what is the dy, which is our height. Because one equation uses dx, one equation uses dy. So as I'm reading this, Peter Prunkrocker decides to dive into a mosh pit. If the stage is 2.5 meters above, if it's talking about above, I would look up. That is my dy, 2.5 meters. A good way to remember the difference between the x and the y, if it happens to say away from you, that's your dx, 1.4 meters. Whereas above is a good way to realize that you're talking about the y. Once I identify those two, now all we have to do is just plug into our equation and ask how long until he lands in the crowd. If it's asking for how long, I'm solving for the time, which is the square root of 2 times dy, which is my height, divided by g. I'm taking the square root of 2 times 2.5 divided by 10. Again, please make sure you're using 10. As I'm getting ready to type this in a calculator, if I'm using Google, I can just type that all right in. Square root 2 times dy, which was 2.5, divided by 10, equals. It's going to give me 0.707, all those numbers. Please check to see what you're supposed to round to. It wants the nearest hundredth of a second, which is 2 places past the decimal point, which you guys will get that if you end up with a number that ends up being less than 1. I'd ask you like to have 2. So if I'm looking to round 1 place, 2 places past the decimal point, if I am rounding this number, I look the digit to the right, 5 or larger, round up, which this is. So my answer is going to be 0.71 seconds. And that is what I'm going to put into the form. 0.71. That's what I want to put into my Google form as my answer. Please do not include units. You can have the 0.7. You can put the 0 in front or not. Both answers are in there. Once I have the time that it falls is also the time that it's going to be moving forward. To find out how fast the object's moving, v equals dx divided by t. The dx I identified as 1.4. Please be careful you do not use the 2.5. 2.5 was my vertical distance. I want the horizontal to find out how fast it needs to be moving. The time, 0.71 seconds. And all I need to do is take 1.4. I'm going to divide by the time, 0.71. And I want to round to the nearest tenth, which would be 1 place past the decimal, which 1.97. That is going to round to 2.0. And that is what I'm going to enter into my Google form for number 1A and then number 1B. Coming over here, we'll do one more together. Again, the main thing that we need to do is identify what is our dx and what is our dy. Our range, the horizontal distance, and our height, the vertical distance, dy. As I take a look, Irene, I love physics, decides to throw a rock off the edge of a 25-meter tall building that is over a river. The rock lands 18 meters downstream from the bridge. How long does it take to land? Again, identifying my vertical and my horizontal. It's talking about a 25-meter tall bridge. If it's something tall, I'd probably look up. That is my vertical distance. So that is dy in this problem. It's going to land downstream from the bridge. That is my horizontal distance, my dx. Solving for the time. Time equals the square root 2 times dy divided by g. When I plug in my numbers, square root of 2 times 25 dy. Oops. Actually, I don't want to put, I usually always write things in parentheses. I don't want to do that because if you put parentheses in the wrong place, you will end up with just taking the square root of 2 and multiplying by the other things in the form. All right, pulling up my trusty calculator again. Square root 2 times my height, 25, divided by the acceleration of gravity, 10 meters per second squared, equals 2.2360, all those extra numbers. My form tells me to round to the nearest, that was 2.0, round to the nearest tenth of a second. Tenth is one place past the decimal. So if it is 2.2, I look the digit to the right, it is less than 5, so I'm going to be leaving that alone. The time it takes to fall is 2.2 seconds. Okay. Again, and I only want to enter the numerical value. I don't want to include the units. It just makes it a little bit harder for the grading. Okay. Once I have the time it takes to fall, that is also the same time that it is moving forward. To find out how fast it's moving, I'm going to take the dx, which was 18, and I'm going to divide by the time it took to fall, which was 2.2. I want to round my answer to the nearest tenth of a second. So 18 divided by 2.2, and rounding to the nearest tenth. So the tenth is one place past the decimal point. I look the digit to the right. 8 is larger than 5, so I'm going to be rounding this to 8.2. So back in my form, I'm not including units, but next I have 8.2 as an answer. Keep in mind, you have 2 more that I'd like you to try in this particular problem set. You have a plane flying at an altitude, 12,000 meters, and it's going to land 3,185 meters away from where it gets released. So keep those 2, maybe those little hints for that problem. All right, good luck on the remaining 2.